good morning to all and the speaker. So today's speaker is Mr. Gangadhara Reddy Donti Reddy, known among professional circles as Ganges Reddy. Uh, is an environmental stability sustainability expert and is also the CEO and co-founder of Blue Drop Enviro Private Limited, Bengaluru. A mechanical engineer by education, he has over 20 years of industry experience, of which a decade was from overseas work in the USA in the field of information technology. After his return to India, being passionate about environment and believing in the best practices for eco-friendly human existence, he chose to get into wastewater treatment, bringing innovation and sustainability into the game to give water a second life. Uh, Wastewater treatment has been a major concern and pain area for government, public, and private organizations alike. With his able team, he is fully focused on delivering sustainable and economical wastewater treatment solutions that are effective and environmental friendly. He is also active in community building through education, training on water related subjects, and providing solutions to rejuvenate polluted lakes. He believes in personal transformation through mediation and has been a heartfulness mediator for over 2 decades. He has also been a heartfulness trainer and mentor since 2012. Along with his wife and two young kids, he resides in the platinum rated integrated green campus of Heartfulness Institute, where the world's largest meditation hall was built, which was inaugurated in February 2020. Thank you, sir, for accepting our invitation and delivering a talk today on waste management and resource utilization. Thank you, sir. Um, so the virtual stage is yours now, sir. And before that, I just wanted to inform you. Yeah, yeah, the PPT is visible, sir, in full scale and full mode. And this session is, it comprises of first and a half 1.5 hour of your talk, followed by 20 to 30 minutes of question and answer sessions. Thank you, sir.
All right, great.
You can start now, sir. Thank you.
Thank you very much for your kind introduction. I thank all your team to setting this up and inviting me to present over the session. Very glad to connect with all the young students and also the professionals and practitioners, and also the professors on this field of wastewater treatment today. During the session, I'll try to cover as much as possible about on the various practices that are prevalent in the industry. I'll try to share practical insights of real-time implementations and the sustainability aspects. So as I speak, some of the things may be challenging the existing systems or belief systems, but these are my observations from my experience in the field. So if you have any questions, please note it down and I'll be very glad to address these questions at the end of the session. Likely this may take about 45 minutes to an hour to go over the details, what I'm presenting, and then I will show you a video also of a real life application of what the technology that I'm talking about. So my request to the participants is to see if we can make it easy to engage and communicate. So if you have any experience or any idea or any knowledge of the wastewater treatment systems, whenever I prompt for some participation, kindly participate freely. Nobody's going to judge or make remarks, but whatever you can share. That makes it easy to interact and also learn interactively. Well, the introduction has been given very briefly. I will just extend a little bit more about my involvement with the wastewater. I lived in the US for a decade. Most part of it was enterprising. I had my own IT company. I worked in the IT industry for more than a decade. But when I came back to India, I had both options. I started an IT company here, building software applications, but I also had the opportunity to invest into an environmental company as an investor. But later on, when I really looked into the details of what these wastewater treatment systems are, what's happening in the industry, it started to really catch my attention. Science started to really fascinate me. So I went about exploring these wastewater treatment systems across India. So I traveled extensively, starting from Hyderabad. My first land that I came to was Bangalore. I went around seeing a bunch of systems in Bangalore, then went to Maharashtra, and then Gujarat, and then went to Haryana, Chandigarh, Rajasthan, UP, Bihar, of course, Delhi, and all that. So I have got a chance to visit personally a lot of sewage treatment plants and effluent treatment plants, starting from say 2 KLD, which is 2000 liters per day treatment, all the way up to 150 MLD. Majority of the systems, or most of the systems, are conventional mechanical systems deployed for treatment. A lot of learnings that I picked up as a part of learning. Then when I understood the subject a little deeper, I started to actually audit the systems to understand how they're functioning, what exactly is happening behind the scenes. So I'll try to share some of the insights, and will be available for any questions even after the session. That's a familiar scenario in India. Which city doesn't have these? There are nalas flowing, there are pipelines carrying the wastewater, and wastewater gets generated from the domestic households, residences, and from industries. What does this wastewater contain? Organic waste, hydrocarbons, fats, oils, fecal matter, a lot of food dump that goes inside, from a household or from a hotel or from any other such public places. The water gets all kinds of treatments, adding different kinds of chemicals, toxins, inorganic, organic waste, and then it flows down to some place. Some of us know where it goes. Many of us may not be paying attention to where this wastewater goes. Are there any people, any members in this forum today who are into environment? You can chat, you can type your message in the chat box. I may not be able to read, but somebody can read the messages for me. Anyone into the environment field? So that's about the domestic water, wastewater. But then now when we go back further, there is industrial segment. Wonderful. Murugesan sir. So we looked at domestic waste. Now we are looking at industrial waste. All these images are covering the wastewater coming from the industries, various industries. There are very many industries. Some of them are low toxic pollutants that they release into the water, but some of them are very highly toxic pollutants into the wastewater streams. And as it reads, there are 14,000 million liters of wastewater generated by industries, but it's a sad fact that only 60% of this is treated. And it will be much sadder to know that out of the 60% that is attempting to be treated, hardly 30% gets treated, and the rest of the 30% gets camouflaged and gets into the water bodies. This is also not an unfamiliar scenario in every village or a town or a city where the water bodies receive all kinds of waste from human activity. This is probably the most familiar image for people living in Bangalore with the Bellandur Lake. What are we talking about here? You're just talking about the impact of this such pollution on the environment. And we are talking about the pollution only in the water here. So the environmental laws say that the wastewater generated from any source be treated. to certain parameters and then be let into downstreams, whether water bodies or nalas are used for gardening or other reuse purposes. There is a legal binding for every institution, whether academic or non-academic or industry or a residential complex. I think there are, if we have more than 40 families living in apartment complex, you are required to treat the wastewater. So while the law prescribes that we need to treat all these waters, to this level, I personally feel it is our moral responsibility or our commitment to the future that all the resources that we are using, as much as possible, we have to resolve the pollutants and make them available for future generations free of pollution. So it is a responsibility from the citizen side too, and from the institutions, whether legality demands or not. NGT is a new entity that has come into picture, National Green Tribunal. They have been going after all kinds of setups because this National Green Tribunal was incorporated with the interest in the country that our air quality is depleting, our water bodies are getting affected, groundwater is getting polluted, and Pollution Control Board is unable to really do the job. So they have commissioned a special force, NGT in Delhi, and they have their branches all over the country. And they have been very actively pursuing and penalizing people who are not treating the wastewater. So because of NGT, a lot of people are taking interest because now they know that the whip is behind their back. So NGT is also prescribing a lot of norms. They have changed the BOD level, COD level requirements. It's not a unknown fact that the Ganga region receives a large amount of pollution. The Yamuna River receives a large amount of pollution, just the way the Belandur Lake receives in Bangalore. When the water is being treated by effluent treatment plants and sewage treatment plants, even then there is something that is called, harming the water bodies. Then the NGT examined and they realized that, the ammonical nitrates have to be controlled, which was not the case before. So they are coming up with the newer and newer norms, guiding the institutions and implementers to take observation and design the systems accordingly. There are several conventional treatment systems that have been in place. India has adopted these technologies from various countries back in 90s or early 90s. Before that, we haven't seen greater implementation of these treatment systems. But when we have downloaded this knowledge from various places, we started implementing this left, right, center, sometimes with understanding, sometimes with not so much of understanding. As a result, Naam ke vaste several systems have been set up, but not many are functional. I'll explain the reasons as we go through these presentations of why, what's, and what is the source of these issues. As people who are interested in a practical future for your own lives, are you all students from mechanical engineering department or various departments are here? Is there anybody from
various departments? I think
various departments. Wonderful, good to know that. So as you see career in real life, and it is very, very imperative for you to, as much as you understand the science and technology ahead of time, apart from your academics, it helps you really focus yourself on where you want to, what you want to achieve. But the system that have been implemented widely across the country have been producing results, but partially. The main systems that we have observed in the market are dealing with chemical treatments, especially when it comes to effluent treatment. And there are electromechanical treatment systems, which are called SBR, sequential batch reactor, MBBR, ASP, and membrane bioreactor. These are very popularly used in both residential and some of the industrial segments. Top of it, every now and then we hear about the biological treatment systems. There are many success case studies, but the reliability and steady state, as mentioned here, has been not very well established. So people are not able to rely completely on a biological treatment. It has to have a combination of things. And of course, there is electrocoagulation that is widely used in some of the industries, but it's very limited in its approach. So if you have not seen treatment plans, some of them look like this. Some of them can be better than this in terms of their look and feel. Some of them can be compact than this, because some of the systems that I'm showing here are, I mean, at least 5 of these places of 6, I have personally visited, taken these pictures myself. You can gather a lot of data just by seeing these images, that these are built with steel and concrete, cement and concrete, and there are steel structures, there are some equipment, there are some pipelines, and the water is visible, and water is moving and is being churned. What else do you see? Anything interesting? Somebody says, I'm seeing blue color. That's all right. There are filters, right? So this is a combination of several things that is displayed here, that it is, these are all the treatment systems that are treating the wastewater. These are the conventional mechanical systems. They are addressing the problem, as I said, but not in a holistic way. What do you mean a holistic way? This word is used in many contexts in life. Holistic approach to education, holistic approach to problem solving. Here I'm talking about holistic approach to wastewater treatment. Somebody wants to say something? What is holistic? Overall. Right. Anything else? Well, we move on. So when I say it's not in a holistic way, so somewhere it is not covering some aspect that is connected with the treatment or the environment or an overall picture. So there are some critical decision-making factors that we need to look at before setting up a system. We can learn about this in the next slide. An integrated approach, absolutely. Integration means bringing everything together, making sure one is not taking a beating because of something else. So that integrated approach is missing in many of these plans. The real concerns on finalizing a technology, choosing a technology, implementing a technology comes here. The first and foremost thing is people still call us as a developing country. And many of us don't deny that. We are still developing, we are still learning. Finance is the one of the most important criteria for us in deciding anything and everything, whether you want to buy a car or a scooter or joining a college or in other ways, finance plays a major role. In some places, finance can take a second role, quality takes a first role. But in many cases, especially when it comes to these treatment systems, I have seen people asking, Kitna padega? That's the first question. Kitna padega? Whether it will treat or not, it's a different story. Kitna padega? And here, there is something called total cost of ownership for the treatment systems when you talk about 10 to 15 years. What is the effective life of your treatment systems? See, typically when you buy a car, people choose between different brands and makes and models. And all of us who are cost conscious, we look at the mileage. How many kilometers would this car run for a given liters of diesel or petrol? Based on that, we know that what is operating cost of that system. And when you have to own a car for 10 years and driving 20,000 kilometers every year, so you can easily calculate how much money you have to allocate for your travel. And then how frequently does it give repairs? Hyundai gives certain amount of repairs, Honda gives certain amount of repairs. A lot of people choose Suzuki because the spares are available at cheaper cost. People, are afraid of Skoda cars because they run really good, but the spares are very expensive. So when we take a total cost of ownership into factor, these are all the things that come into play to define what is the total cost of owning a piece of equipment or a treatment system or a home. And then there is effective life. I have not seen a car running for 30 years. Of course, it may run, but we do not use. Most of the cars I see, 5 years, 6 years, 10 years, 12 years, maybe 15 years. After that, even the local government do not allow you to use those cars. But in case of treatment systems, what is the life of your treatment system? If you really examine that, that would decide. I ask this question to most of the civil engineers. When you design a building, when you design a home for yourself, when you build a home for yourself, what is the life of this building? How long do you expect does this house or villa or apartment to provide shelter to you? Can you throw a number? 5 years, 10 years, 15 years, 20 years? 20 years. Okay. Any more answers? I'm building a house now in Hyderabad. My anticipation is that this house at least serves me and my sons 50 year. On average, I'm looking at a 50-year life for the home. In these 50 years, at the most, I'll be doing a couple of coats of paint, maybe some repairs on the plumbing, maybe some tiles broken, pretty much, are some electrical fittings. Other than that, rest of it is fridges and all that. That's user specification that are different from the building. So average, we are expecting a 50-year life cycle for a house. And how much do you think we will be spending to maintain this house for 50 years and operate this house? This is a wild question, but a lot of people have answered in the past. Maybe about for a 20-year period, if you consider for a home, we may be spending 10-15 lakhs approximately for the painting and all that. Maybe 10 lakhs, maybe 20 lakhs, depending on where you are. If you're by the sea coast, you may be incurring more expense. If you're in the good weather conditions, you may not have all that nuisance, but that's the kind of expense. If you build a house with a 1.5 crore capital, you're spending some 15 lakhs for 10 years, let's say. We're talking about 10% cost of operations and maintenance for this home. When it comes to sewage treatment plants or effluent treatment plants, if you set up a treatment plant worth crore rupees, in a 20-year period, if the system survives 20 years, if at all, you are going to spend an average of 4 to 5 crore rupees for a 1 crore capital cost. You're spending 4 to 5 crore rupees to maintain it and operate it. There are two different things. Operation is different from maintenance. Operation is you're running it. When you run it, it consumes fuel, which is electricity. There are significant electricity costs around sewage treatment plants and effluent treatment plants. And then you need technical operators to be available. And then you have to remove the sludge from the system. When you operate, these are all the things that you operate. Then comes to maintenance. What is maintenance? There are pumps repair, there are blowers repair, there are plaster peeling off, or pipes rusting, walls choking, things like that. There are all maintenance things that you have to maintain. The filters choking, you have to replace the filters, all kinds of things. They are the maintenance part of it. So now you have to look at how frequently these systems cause repairs and maintenance. And can you afford the breakdown of your system? If your RO system in your house breaks down, is it really going to be big trouble for you? For me, at least, it's not. I can go buy a couple of bottles of water and come back home and happily drink, or maybe order for a bubble and it will serve me for a week. That's all right. But imagine if the water is not going out of your commode, how is the situation? And same way, imagine, excuse me, I have some background noise here. All right. So we can tolerate that. Similarly, if a STP stops functioning, it's called breakdown. Can you afford it? Then is the system institution appropriate? I have not been to MSRIT, but I'm sure the ambience in the college must be green, clean, well-maintained buildings. And if we set up something obnoxious, that's where it's written, does your system cause objectionable orders? You built a great villa complex and then you set up a system where it makes noise all around the 24 hours. And then it starts to stink and smell. Would you like it? Is it appropriate institutionally? Today, we are talking about setting up regeneration of lakes. And we are talking about setting up MBBR systems, SBR systems, and mechanical systems by the lakeside. Lake means a natural ecosystem. It has water body, it has flowers, it has plants, it has trees, birds, vertebrates, all kinds of very natural ecosystem. You go there and set up a heavy duty mechanical system. How does it look? Does it look appropriate institutionally? And moreover, if you go set it up in, if you go set up such a treatment plant in a village, how many engineers are willing to go stay in a village to take care of such things? So the systems have to be institutionally appropriate. And what kind of skill level is required to operate the system? Say if the operator fell sick, what happens to the system? So these are some of the facts that we need to look at, in setting up or deciding a system. Then goes environment. Since I lived in the US for a decade, I would say apparently, although the US has done a lot of damage to the environment by their advancement in the industry, but as they woke up to the pollution, they started to give a very high priority. There is something called EPA, Environment Protection Agency. They mandate such a stringent rules that everything first goes for environmental clearance. Only when the environmental matters are addressed, then everything else moves. Cost is not the primary factor there. Environment is the primary factor. Then comes everything else. Unfortunately, as a developing country with limited resources and not understanding the impact what we are causing on the environment, we are taking environment as a third least important step. Let's say we consider environment as a factor. So now is your system environment friendly? What is the carbon footprint of your STP or ETP? And can your system meet the newer and newer NGT norms? Although you have set up the system, how safe is the treated water for reuse or release into the downstreams? We have read in the news coming from River Ganges, where people have set up large sewage treatment plants, and then they found that the fish is dying in the water. Why? We are supposed to have curbed the pollution by setting up the treatment plants, but now they're talking about fish dying. It was like a shock to many people. What would have happened in many cases is that when the treatment system doesn't function efficiently, to camouflage the deficiency of such treatment systems, people tend to dose a ton of chlorine into the water. And then nobody does dechlorination. And the same water flows merrily into the streams. And chlorination naturally is acidic. Takes away all the microflora from the water bodies. The water that we drink has millions and millions of microbes. And most of them are very friendly microbes. They help our gut also. It's not a problem. Only when the water gets polluted, where pathogens come into the picture, that's when the water is a problem for us. So when you dose chlorine and then this chlorine hits the water, fresh water, most of the microflora is disappearing. And that's how the fish is affected. And the fish, when they lay eggs, when it's exposed to chemicals, that also goes away. So one significant part of the ecosystem we are terminating by applying such a unmindful chemical dosing. So these are the real constraints that we have to observe in understanding a system, designing a system, or choosing a system. We talk about sustainability everywhere. We talk about sustainability as your youngsters. Now, when you go into real life, you start to build your home, you start to take employment, get married, whatever. The first matter that comes is, can I sustain my life with the income that I have? What do you mean by sustain? It's not about just paying your rent. Sustainability has multiple pillars. In environment, when it comes to wastewater treatment systems, we define sustainability as something given here very clearly. While we treat the water to provide clean water and healthy environment and do not disturbing the equilibrium, a sustainable system has to be economically viable. Socially, it must be acceptable. Technically, it should be appropriate. Institutionally, it should be appropriate, and it should protect the environment and natural resources. People ask, what is being socially appropriate or acceptable? We develop a colony, there are 200 plots, and one of the plots I allocate for STP. I bet nobody would come even closer to the STP. Nobody will buy those plots because socially these are not accepted. They're not acceptable. So these are the various factors that we need to look at and meet at a place where it is comfortable for all of us to call it as a sustainable system. A lot of people loosely talk about green technology. And when you ask the definition, it is what is shown in the dictionaries. It's technology whose is intended to mitigate or reverse the effects of human activity on the environment. Often that clean tech or green technology refers to technology that is considered environmentally friendly. That's the first thing, based on its production, process, and supply chain. While it's being produced, while it's being processed, and even in the supply chain, nowhere it's to disturb the equilibrium of the environment. Supply chain. I just take a simple example. Every second day you're importing things from, say, Delhi or from Varanasi or from Jaipur to Bangalore. This whole supply chain has so much of carbon footprint because of the trucks carrying such loads of stuff that is being used in Bangalore. Rather, we should be using stuff that is locally available. So we minimize this carbon footprint because of this entire supply chain. So that's what is green technology is called, that uses natural resources, locally available resources to provide the required service. Now, if you talk about a little bit more to jump back a bit, the water that we use, how many of you know how much of water an individual uses per day? Any of you have any answers? How much of water an individual uses per day? Are there any norms around average consumption?
Hello, sir. Hello, sir.
Yes,
Average consumption is about 135 liters per day.
135 liters. Fantastic. I think that's what the government says.
Yes, it is about 135 to 150 around.
Right. So national standard says, it's about 135 liters per day. So can you guess how much of this 135 liters gets really used and how much of it gets converted into wastewater? Any idea?
About 80% can be used out of 35 to 150. And nearly about 80% which comes as wastewater.
Absolutely. So in about 80% of the water out of 130, you can probably mute yourself.
Okay.
Out of the 135 liters that we use, about 80% of that water converts into a wastewater. And that wastewater goes out of our homes into, where does it go? You can type in the messages if there is background noise. Where does this wastewater go? No responses?
It can
Sewage.
sewers. Then inter
Wonderful. Thank you for the responses. Much appreciated. Yes, this wastewater goes from our home and goes into drainage lines. And sometimes it is in a end-to-end drainage line that the entire wastewater goes into a sewage treatment plant somewhere set up. It goes into tank, collection tank, and then goes into sewage treatment plant, or it goes into a pipeline and it goes out of our complex and then gets into a nala. And this nala goes into probably a bigger nala, and then that probably may go into a water body, and that water body overflow may go into another water body that may end up in a river, which may end up in an ocean, or directly these wastewaters are going into rivers if the industries are set up by the river bank, and if they don't treat it, they will let go into these water canals and channels and all that. Ideally, this all is supposed to go into treatment plants where we are supposed to be treating this wastewater. Now, when it comes to different kinds of systems that we discussed, and then we talked about electromechanical components and we talked about sustainability matters, we can talk about problems all day long, but what are the solutions? Are there solutions available? And how different are these solutions differ, from the systems that are throwing a lot of challenges? One of the solutions that has been practiced very widely in the Europe and the American countries is constructed wetlands. This has been an inspiration drawn from nature that majority of us would have seen in a semi-urban or rural setups where there are water bodies and you can see certain kinds of plants growing in the water. These are aquatic plants, meaning aqua. They survive in waterlogged conditions. Like the plants grow on the soil, they also grow in the water. They may need some soil base. Some of them don't need soil base. If you say Jalkamal, that it doesn't need any soil base. They will be um, floating on the water itself. But these plants that you're seeing in the water body, they are somewhat a marshy land aquatic plants where they're taking root into a marshy land, but they're in the waterlogged conditions. When you go closer to them, most often times you find some kind of bubbles coming up from the bottom of this. And when you really closer and observe, people may say they are poisonous gases. Some people may it's releasing some gas or oxygen, whatever it may be. The plants, we know all of them release oxygen from their leaves. Similarly, they release nascent oxygen, hydroxyl ions at the bottom of these plants, roots. So when we talk about wastewater, the characteristics of the wastewater are defined as COD, BOD. I do not know how much of it is taught to you, known to you, but I will make it very simple for you. In the wastewater that we use, when you wash your hands with soap, yes, it has soap in it. Then you wash this, use this water to wash your clothes, it detergent in it. If you wash the vessels, it has the chemicals in it. Then you use shampoo, shaving, all kinds of things get in contact with this water and gets carried away. And when you wash your hands after your meal, yes, the food particles are going with the water. When you wash vessels, a lot of food particles go along with the water. So all kinds of organic, when you go use the toilet, urinals, the fecal matter, the urine, all that goes along with the water. So there is organic matter, there is inorganic matter going along. You cut some papers here, plastics there. I have seen all kinds of really nasty things in the sewage waters and effluent waters. I have seen, combs coming, plastic bottles coming, caps coming, shampoo sachets coming. Strangely, you will find coconut oil bottles, even 1 liter, drinking water bottles and all kinds of stuff. And if you go to the municipal wastewater treatment plants, you would not believe what and all comes into that water. So it's unfortunately, there's a mix of all organic, inorganic, chemical compounds, and some of them can be very toxic. And if it's industrial wastewaters, it can get in contact with some heavy metals, and the metals may be coming into the water. And places where there's fluoride and all that in the water, in the borewell water itself, naturally all those things go along with the water after use. So when organic matter comes in contact with the water, like food, food has bacteria, and that bacteria needs for its survival oxygen. The same bacteria that is getting mixed with the water starts to take away the oxygen from the water, creating biological oxygen demand. Similarly, the chemicals, when they mix with the water, they take away, they oxidize with the oxygen, and then they take away the oxygen levels in the water. So chemically, there is oxygen demand created. Biologically, there is oxygen demand created. That's where the COD, BOD comes into picture. If we have more acids or chemicals in the water may become acidic. The pH level starts to go down. And total suspended solids, it depends on what kind of solids you are adding into the dirt and all that, adding into the water. So the total suspended solids that are very fine particulate matter that goes into the water, it gets disintegrated. So that defines TSS. And then of course there is total nitrogen in the water, there are sulfates in the water, there are phosphates in the water, and fecal coliforms coming from sewage. So all these kinds of stuff is there in the water. In conventional systems, typically we try to provide oxygen to the water, which is deprived of oxygen biologically and chemically. When you provide oxygen to the water, it recoups, and the BOD levels, biological oxygen demand levels come down, chemical oxygen demand levels come down. These two things come down, and the water starts to recuperate. In the process, you try to settle the suspended solids and take the supernet water into further processing. This is typically what happens in the wastewater treatment system. Here, when you see these plants, when the plants are releasing nascent oxygen, in conventional system, you are supposed to deploy a blower. You're supposed to take the ambient air and then pump the air into water. For every kg of air, how much of oxygen goes into the water? Any guess? For each kg of air that you pump into the water, how much of oxygen is actually transferred into the water? There is something called oxygen transfer rate, OTRs. Typically, the content is about 15%, but the net transfer rate somewhere around 6% or lesser than that. So for which we deploy all those equipment that we have seen in the images earlier. But here the plants are providing that nascent oxygen, no machine deployed, no energy required. They are providing that oxygen. So that's how the plants can contribute to the treatment of the system. And there is bacteria associated with each of these plants. Different bacteria gets produced at the root system of each of these plants. And that bacteria actually disintegrates the waste that is coming in contact with their roots. And that converts into a food for the plants. So there is a symbiotic association between the bacteria and the plant that helps the treatment in a natural setting. That is how our water bodies used to recoup very fast and used to have a very healthy environment. But in the past 30 years, due to rapid urbanization, industrialization, and severe pollution, plus kubjifying the shallow water bodies, meaning if the water body depth is hardly about a feet or 2 feet, people dump debris there, occupy that land, build a building and sell the land, all kinds of atrocities across India. I have seen this not in one place. Every place it's a similar story. So now there are no shallow water bodies left for these plants to grow in marshy lands. Now shallow water bodies are deep. And even if there are shallow water bodies, the water pollution, chemical pollution, the toxins are so high, some of these plants are unable to treat that water the way they used to treat 20, 30 years ago. So we came into a situation where the natural systems are also not helping. But drawing the inspiration of the mechanism that treats the water, people have come up with the engineered systems that are called engineered wetlands or constructed wetlands or phytoremediation techniques. Phyto means plant, remediation is remediating. So these are the systems that have been popularly deployed since 4 decades. Some of the countries in the Europe mandated that they only should use treatment systems based on the wetlands because they do not cause a secondary pollution and they are natural environment. You don't deploy a lot of energy here. So when you read the definition of wetlands, which are naturally formed and have been at work regenerating water, popularly recognized by the sustainable experts as Earth's kidneys, like kidney flushes the impurities from our the water in the body. Likewise, these are the Earth's kidneys that do that natural function. They filter impurities and pollutants from our waterways. Constructed wetland systems are man-made and they are in a way oxygen supplying biological engines. They are not mechanical engines, which can treat all types of wastewater, domestic, municipal, and industrial. It cannot treat all kinds of industrial waters, but water analysis to be carried and it has to be deployed knowledgeably. So as a company, we have done a lot of research. We have implemented these systems across the country. This is one of our partners from Denmark. He has done more than 1,100 projects on this technology. His name is Rene Killian. These are some of the systems that we have built in India. He had come to India, seen the system. This is how the plant growth has been very impressive. There are, what we practice is something much advanced. It's called aerated wetlands. Aerated wetlands are one step above the natural constructed wetlands where we provide some kind of aeration at the bottom of the wetland. We use mechanical equipment, but these are very, very, very insignificant power consumption and lower capacities compared to a conventional system. But these ones are helping us reduce the footprint because India also is in need of a great trouble because of the real estate challenges. We cannot have a lot of land available for systems. For that reason, to make sure the wetlands propagate, we have taken this technology, we brought it into India, we started implementing where instead of using 1,000 square meters, now today we are using about 100 square meters. We have reduced the space requirement by 90%. Earlier, we used to take, for every 1,000 liters, we used to take about 10 square meters. Now we are taking about 1 square meter, but it depends on the pollution, also depends on what and all is in the water. So these are some of the systems. When we compare the technology, the aerated wetland systems that we practice are natural, they take minimal power. And the electricity consumption is very minimal. We never dose any chemicals into these treatment systems. Something called sludge. What we need to understand is when you get this organic matter into the water and inorganic matter into the water, whatever is not digested becomes a sludge. In conventional systems, you actually dose agents like alum to coagulate and create heaviness in this suspended solids. They all settle down at the bottom of the basins, and that supernate liquid is taken out and it's treated. And all this sludge that is accumulated has to be extracted from these basins. It is compressed, sometimes it is heated, then it is carted out to some other places. Sometimes it can be used as manure, but many times it may not be suitable as manure also. So this sludge handling is a big nuisance in treatment systems. Some places you have to handle it every day. Some places you may have to handle it every week, but it's an additional expense, additional effort. It also takes energy, and it also requires footprint because you're dumping it constantly somewhere. In these wetland systems, you don't have to deal with the sludge because majority of the sludge, which is organic, gets consumed in the system itself, that it doesn't produce any secondary pollution. The maintenance cost is low to medium. You don't need any great skilled manpower here. A part-time gardener can run the system, take care of the system. There are hardly any repairs and maintenance. It never breaks down. There is nothing there to break down. Effective life can be up to 40, 50 years. I have seen a system in Philadelphia. It was built in 1954. Till date, it is functioning. It's probably 70 years, so almost 67 years. Land requirement has to be done case to case basis. It provides a clean and green environment. Systems look like parks. With age, these systems appreciate. As the plants grow, as the root system establishes stronger and stronger, it can take larger loads of pollution and can treat it. Conventionally, mechanical systems actually, they go down as the age because of the wear and tear. So environmentally, these are extremely friendly. Eco restoration, yes, these systems act as green lungs. They are bio hotspots that they attract birds, bees, butterflies, all kinds of elements of the nature. And nutrient handling, it is very efficient. You don't have to do anything different for it to consume the nutrients. Very minimal carbon footprint. You can get carbon credits when you apply these systems, and you don't have to disinfect this water as much as it is required in conventional system. If you have to dose chlorine, you just need to do 1 ppm here, while you have to do 4 to 6 ppm in conventional mechanical systems. There is something called humic acid that forms in the base of the wetlands that has different kinds of mechanisms that actually kills the pathogens. And wetland, when you look at the root system, it's a very complex engine. It has very many different kinds of species of bacteria that is developed, and majority of them are anti-pathogens. That's what we have noticed after a lot of research. We can use this system. You can use them in residential complexes, small townships, large townships, commercial kitchens, food parks, office buildings, recreation. You can put them in parks, golf courses where the large amount of water is required. They are deployed in municipal corporations, smart cities, lake resonation, railways, industries. We have implemented all at these different places, what we have written here. This is what Central Pollution Control Board recommends, that it is clearly given here. Disposal of untreated urban wastewater has been a major cause of water pollution in India. Strategies for control of water pollution caused by municipal wastewater have focused mainly on implementation of expensive and energy-intensive conventional treatment technologies. The limited successes of such strategies can be attributed to the high capital cities. The criticality of cost-effective, appropriate wastewater treatment technologies for water pollution control in our country hence needs no emphasis. In recent years, constructed wetland systems have emerged as low-cost, high-performing wastewater treatment technology in many European and American countries. There is a growing interest to develop and adopt this technology for water pollution control in India as well. This publication provides a detailed overview of the concepts, pollutant removal mechanisms, engineering design, construction, operation, maintenance of constructed wetlands for wastewater treatment. So this was published in 2001, almost 20 years ago. But unfortunately, the awareness has been very minimal. That's why we do not see a large amount of systems in the country. There are very few. Even those few systems that are built, I've witnessed, I've visited some other treatment systems established by various companies, show a very poor understanding of the science. It is not about growing some plants. It has to be calculated that every square meter, how much amount of load can be treated. If we approach this science without understanding the nuances of treatment, they end up being systems that clog and they start to become obnoxiously ordersome. The water becomes pale yellow, then they turn into yellow, then they stop treating. So although the science works, but people should understand the science to the details to be able to make it work. We have started practicing aerated wetlands versus passive wetlands. Passive wetlands were what we have done for about 4 years now. Since 2 years, we started going towards aerated wetlands because we have seen this clogging in passive wetlands. We have seen ordersome situations in passive wetlands, and they also require a lot of land. And in cases today, you have designed the system for 150 BOD, but tomorrow you see that the BOD is coming at 250. Now, what do? You have no recourse. So these aerated wetland systems provide that opportunity that you can fine tune the aeration to a few or more hours, then it addresses the additional pollution. So there can be a lot more control when you implement aerated wetland technology compared to a passive wetland technology. So people must be wondering, what are these systems that I've been talking, how does it look? These are the 3D images. To easily explain, the water comes into this screening chamber, it goes into pumping station. From there, we pump into a holding tank just to create gravity. If the land already in configured in such a way that you don't have to do pump, you don't need to. It can grow by gravity. Otherwise, you pump it into the holding tank, it comes into the first wetland, then goes into the second wetland, comes back into treated water treatment. It is very simple. There are 2 treatment beds that are there. It's called wetland cells. This is another, the bottom one is a system that we have implemented with Western Railway in Ahmedabad. This is where we wash railway coaches, and there is fecal matter coming from the railway coaches, from the toilets, and all the dirt and everything else, floor wash comes into the water, and that water we take, treat it, and completely, make them reusable. We send it back into the lines to wash the coaches again. It's a very successful project we have done. This is a Nala application where one of the district collectors wanted to do a pilot scale. So we intercepted this Nala, taken the water into that white holding tank, and then fed that through the wetland system. And this produces clean water. There is hardly anybody there to maintain it. It continues to function. This is University of Hyderabad. Unfortunately, the system doesn't exist now, but when it functioned, this is how it looked. It looks like a greeting card. Very rarely anybody can recognize that this is a treatment system. This is ICICI Jodhpur, where there is a rural self-employment training institute. They train people and they wanted to go for a complete green building. This is built with the local stone here. That's why you see the Rajasthan stone. The entire building is on green principles with IGBC. They're a platinum rated building. They wanted to go natural technology. So we did a 20 KLD. I'll show a quick video of this later. This is a CETP, common effluent treatment plant we have set up in Hyderabad. The inlet water is this, outlet water is this. No chemical, no machine. This is a passive wetland. We're taking a lot of space, but works amazingly. We have published papers on this in international journals. It was presented in Denmark in 2019 in the International Wet Pole Conference. This is another excellent case where Raipur in Chhattisgarh, the steel industry is struggling for water. There is a Nala passing by. It is actually carrying the wastewater from a village, and this Nala was stinking, and they are also falling short of water. So they said, what can we do? So we intercepted the Nala, took all the water into this treatment system. We treat the water. All that water now goes back into their process, into the steel industry, and also part of it used in the gardening. So the waste is converted into wealth here for the steel industry. This is another typical case where 150 KLD treatment system was functional. There is a golf course behind this. This is NISA, it's called, where the CSIF Jawans are getting trained here. They had a conventional system which defuncted. So we use the existing tanks. We said we remove all this electromechanical equipment and all those basins, but existing tanks we have used. We have built these wetlands behind it. We were able to build this whole thing in 60 days, and it produces outstanding quality of water and matches the environment that is a golf course. It beautifies the golf course. This is another system, very peculiar in its nature, very unique system in entire India. This is called Kanha Township. I don't know if you have known of this facility, Kanha Shantivanam, where world's largest meditation hall was built. About 1 lakh people can meditate. This is a Heartfulness Institute, world headquarters. There are people, 1,000 to 2,000 people in a normal day, but there are 5,000 people in a weekend. Sometimes there are up to 1 lakh people when a large event happens. So the system has to scale up from being 1,000 people system to all the way to a 30,000 people system, because one part of the water comes here, rest of it goes to another plant. So we designed the system in a beautiful way where it functions when it's at 200 KLD. It also functions when it's at 2.4 MLD. You don't have to run around, nothing. Have a good cup of coffee. Couple of chairs are visible in the picture. You sit there, watch the fun. The system functions smoothly. You just need to change the settings of the blower to function for some extra hours, and then you dose some external bacteria. So and it functions really, really well. So I have some questions here. What kind of technology Israel have for treating with seawater drinking purpose? All right, we'll answer this question. Someone can read these questions for me. Now at the end of the session, I would not miss this. Then this system that I just showed you, you don't understand what the system is. You can see the curves. Actually, the design is this. We talked about wetlands as the kidneys of the earth. taking the inspiration, we wanted to create the system in a kidney shape. So here is the system. That was a drawing. People thought, is it really practical? Yes, we did it. That's how the drawing is, and that's how the implementation is. In some places, they wanted to have a lot more aesthetic. It looks like a park. Yes, we designed systems in a way they all look like parks and they blend with the nature. Some place where they didn't have land and they said, we need to get this is for a high court building in Nagpur. They wanted to create a system in 60 square meters. They wanted a wetland system. So we did is a G+1 structure. At the bottom, there's a wetland. At the top, there's a wetland. There's a holding tank. You can see the ground level here. Part of the holding tank is below the ground. Part is up. Then we have wetland here. All these sites are all open where it receives the sun light, and top it's all wetland. So we can design systems in many different ways. And then this talks about lake rejuvenation. Every lake is receiving sewage in India, and most of the lakes receive. So we can intervene this lake scenario and feed it into the wetlands and build in thoroughly, and then release every drop of water back into the lake. But no drop of water goes without passing through the wetland system. So these are some of the system we do. Floating wetlands. Some of these floating wetlands are so robust. These are not those YouTube videos and WhatsApp videos that are getting circulated everywhere that we did floating wetlands and they're functional. 90% of these videos are, I would not say fake. Most of them do not work. It depends on how much of root biomass that you're able to create per square meter or per cubic meter of water, because bacteria has to be in that proportion. Only then the treatment happens. Otherwise, putting some canna plants and from floating thermocol doesn't treat. This is far behind when it comes to engineering such practices. So specifically, I wanted to talk about something. A lot of people we have gone through this phase 1 and phase 2 of lockdowns because of the COVID and anticipated third wave. What do we do? How do we do? We all have to pay attention. This is not a professional forum where you can contribute, but generally, just for your information, all the antibiotics that we take, the residuals go into the water, and it is found in the wastewater through extensive water study in IICT here in Hyderabad and in US and many other places, that they found SARS-CoV virus traces in the wastewater. If a COVID patient is in home and he's defecating, and obviously the virus is traveling along with the urination and fecal matters, and that goes in the treatment plant. And then naturally, if somebody is touching this water, we are standing in danger there. And if you really see if you remember the images that I've shown you, where wastewater treatment systems have large basins and this water is being churned to provide oxygen, naturally, now the virus is in the water. And COVID, a lot of us do believe now that it is prevalent in the air also. So we have to be very careful with handling wastewater in these COVID times. Today is COVID, maybe tomorrow something else, but our treatment system should be designed in such a way that where their water should not be exposed to ambient air ever. And water, there should not be a need for anybody to put their hands into this waste. Everything must be in a way such it should be automated. Only the final water should come out, and that water should be free of any pathogens or virus traces. So there are growing concerns in the environmental concentration of antibiotics exert a selective pressure on clinically relevant bacteria for the control of such acute strain. There is a need for major shift towards a more localized management of water cycle. If you did not treat your wastewater properly and you let it go into water body, now the entire water has virus traces. So we got to be very careful about handling this wastewater, whatever we are doing. And there has to be preventive mechanisms. Some of the recommendations we have for people is avoid direct contact with the wastewater anytime. Avoid exposing the water during the treatment to ambient air. And do not let the water go into soil or water streams until a thorough disinfection mechanism is established. We highly recommend ozonation of the treated water as a tertiary. So there is no trace of any biological presence in the wastewater. So these are some of the things that I want to share with you about our company. You want to know about this fellow in the beard. His name is Scott Wallace. He invented this aerated wetlands. His MTech environment in the US. He received 3 National Excellency Awards in US for his work in the wastewater treatment design. He invented this technology and he gave the technology to various countries. And the tall fellow is Rene Killian. He's one of those people who use this technology. Scott himself has implemented about 250 different systems, all the way up to 79 MLD, while Rene implemented a lot of domestic systems. So these are our partners that provide technology and advice. Since they have seen this for 30 years, we derive a lot of experience from them on various nuances, how systems function after 10-year, 15-year period, which we have not seen in India. So these are technological consortia. We do STPs, ZTPs. We also are experts in fixing STPs, like, set up an STP already. There's a mechanical system present, but it has order. You don't know what to do with it. We know what to do with it. And there is water is not getting treated sufficiently. BOD is getting stuck at 40. Now we don't know what to do with it. So there are methods and easier ways to actually augment the treatment efficiency to bring it under Pollution Control Board norms. So these are some of the applications that we have. Then we are, as academic interest, we are members of various societies across the world that are focused on wetland science, and we also have filed a patent with for our work here in India. So our call has been to decision makers. Now you are academic community here, but wherever you are heading in your life, whatever you are doing, if you come across the wastewater treatment systems, or you are educating wherever you are living, it is very important that we take certain things into our hands for sure and advocate right things for the right environment. Unless we bring sustainability to the wastewater treatment, a point that I forgot to cover is that in Hyderabad, in Bangalore, I have visited umpteen number of installations. Very sad part is that every system has a backwash or a bypass provision just to make sure when the system is under maintenance or when for a backwash, they give provisions. A lot of communities have used conveniently to just bypass the entire treatment into an ala because that bypass provision is there. Why are they doing this? It's not fun. They set up the system because, like I said, a 1 crore house doesn't cost more than 10 lakh, but a 1 crore STP costs about 20 lakh, 4 crores, 5 crores for maintaining. People, when they do not understand that it takes so much expense and they sign up for these things, when they are faced with the reality, when they have to spend 1 lakh rupees, 2 lakh rupees, 3 lakh rupees per month to maintain the system, they find it very difficult. They bypass it. So unless we bring down the cost of treatment, unless we bring sustainable treatment systems, all the well-intended people are also using easy methods to just stay right with the legal requirements, which is a very unfortunate scenario. So fellows, thank you very much for your time. This is what I wanted to share with you today. Well, I think I owe you showing a video. Probably let me do that. That will give you a little bit more insight into how a treatment system functions. Any questions before I show this video?
I have one question.
Sure.
Operation and maintenance cost is
Right.
more than the installation cost of any domestic residential complex STP.
Yes.
Much more.
Much more, much more.
Much more. And where has been the constructed wetlands installed in globally?
Globally, there are thousands and thousands of installations have happened, and there is no other technology other than wetlands, which has thousands and thousands of online papers published by various scientists and professors, doctorates across the globe. If you go construct wetlands and start reading, it never ends. There are thousands and thousands of papers. They're all published based on pilot case studies and also real-time implementations. Many countries have thousands of implementations. India, we ourselves as a company have implemented 70 systems. We in Delhi, with Delhi Metro Rail, we implemented 13 of them. With HPCL, we have implemented about 17 systems. With IOCL, we implemented about 5 systems. We have implemented in some universities. Right now, we are implementing in Vignan University in Guntur. We have implemented in CMR in Hyderabad. Then we are implementing one in Geetham, Hyderabad. We have implemented for Welspun Engineering. We have done it for very many. And with railways, we implemented about 4 systems. We are implementing another half a dozen with railways. So there are very many places we are implementing these systems, and we have implemented as effluent treatment plants. In one of the cases that we take pride in implementing is with HPCL LPG unit, where our domestic cylinders are taken for wash for leak testing. To test, every cylinder gets tested again and again for leak proof. So when they wash it, ethyl mercaptan, which is the ordering agent, that comes into the water, and butane comes into the water. Then the cylinder rust comes into the water. Also, they have a canteen and they have toilets there. when such a complex water stream comes into the wastewater, they tried everything, including RO, nothing worked. RO actually, the membrane choked because of the rust. So we went in and we implemented wetlands there 4 years ago. System has been running seamlessly. We implemented for HPCL lube oil, where there's a lot of lubricant oil coming into the wastewater. We implemented this in Silvassa 5 years ago. System has been successfully running. The CETP we implemented that I've shown earlier. And another food park here, not just a food park, it's a heavy duty kitchen like Akshay Patra. They cook, the Green Park hotels, they cook for 22,000 meals a day, and receives heavy loads of food and inorganic, and also a lot of chemical load when they wash their vessels and their sheds and all that, cleaning areas with heavy duty chemicals to keep it clean. A lot of chemical dosing happens. The BOD comes around 1,000 and the COD comes around 3,000 on a normal. And a heavy day, the BOD goes to 2,000 and chemical COD goes to 7,000. This is the only system that works in such an environment at that cost, at that footprint. So we have implemented it very successfully. Without any tertiary treatment, we are able to solve these problems. There are very many case studies. I do not want to bore people with the work we have done, but I can only say that these systems are proven. We have been implementing. We do not implement conventional systems as a policy. Sometimes we are forced to implement conventional system, but so far all the 70 systems we have done are wetlands based systems. Earlier it was passive wetlands. Now all the systems are aerated wetlands.
And constructed wetland has a lesser space than natural wetlands, is it?
Of course, yes. Natural wetlands would take a lot of space. If they take about 2,000 square meters to treat the wastewater, we may be taking about 2,200 square meters. So it's a lot lesser. Passive wetlands, if they take, say about 100 square meters, an aerated wetland will take about 20 square meters. That's the kind of proportion we have seen.
So is it justified to replace natural wetlands, which is existing in India, with the constructed wetlands? Because nature is a God to us, and they have, there is natural wetland, which is called Ramsar site, existing in India. And everybody is destroying it by building residential complex and commercial complex, business houses and all this industry, and they are regularly destroying it. So is it possible to construct a constructed wetlands in place of natural wetlands? Because natural wetland has a huge area, which is called Ramsar site.
So to answer your question, it is really sad, very sad. Personally, it is very sad for me whenever I see this kabjafying of natural wetlands. We are calling for trouble. We have seen tsunamis, we have seen different kinds of things. Any part of the ecosystem should not be mishandled like that. Natural wetlands should never be touched. Illegal, actually, in a sense. But
right.
So, and we should never replace natural wetlands with constructed wetlands. Constructed wetlands are engineered system we should be using to deploy additionally apart from the natural wetlands. Like, you have a community, like in a university, you want to do STP, go for a constructed wetland. But if there is a lake, it has a natural wetland system, never disturb it, because it has amazing wealth of natural microflora that is present. We should never touch those.
Thank you.
Let me turn on my video here to show you a quick video. I'll show you two videos. One of that is
excuse me, Gangadhar.
Yes,
Hi,
please.
good afternoon, everyone. This is Selvakumar Margar. I'm friend of Mr. Gangadhar. While going through this chat and the questions raised by so many, just two questions is there. I request Mr. Gangadhar to address on this. One is somebody has asked that the concession time compared to the conventional, compared to the wetland will take more. That is one thing. Gangadhar I request Gangadhar to address on this. Second thing is one more gentleman who was asked that how wetland technology can handle the various types of the BOD.
Okay, so the BOD itself is like a, I don't know, people like paneer these days a lot. A lot of it will be, it's like a paneer to the plants. Biological load is what they thrive on. These wetland plants, they need manure. You know, in fields and agriculture farms, what are we doing? We are bringing manure from somewhere and dosing it into the farmlands so that the plants grow. So all the biological load is the food for these plants. So if the varying biological loads can be handled by supplementing the wetland, let's say I have built a wetland for a 100 KLD plant, which is 1 lakh liters per day. And I've taken inlet BOD as 200. I designed the system, engineered the system, built it, it's functioning. Suddenly there is a 300 BOD coming in, which means that there is more load on the system. Often the wetlands can take that shock load and treat it themselves. The way they're designed, they can handle such loads. But at the same time, we as a company, when we encounter such circumstances, we dose external bacteria into the collection tank. This bacteria is exactly a friendly bacteria similar to the wetland plants bacteria. We extract this bacteria from the root system and we compile into a artificial bacteria. When we dose this, it actually does pre-treatment and it reduces the load by the time it goes into the wetlands. So that's how we actually handle varying loads of BOD. Also, since we practice aerated wetlands, instead of running the blowers for 8 hours, sometimes we run it for 10 hours. If the load is higher, I don't need to do anything. Just increase the blower time, it addresses the load, which is not the case with any other systems, because other systems are already designed in a perfect scenario for all 24 hours. Any extra load, they may find it very troublesome. And when it comes to construction time, constructed wetlands can be built very quick. Of course, it depends on the rainy season, which affects any construction. We have built a 2.4 MLD in a record-breaking 55 calendar days. This is a record in India. Nobody has built a 2.4 MLD system in 55 days, but we were able to do it. So systems can be built. At the same time, we have built a 100 KLD system in a year. It depends on so many factors: the fund availability, the area clearances, and the cooperation from the management and the contractual requirements. But systems can be built very fast.
Thank you, Mr. Gangadhar. I hope so. It will be clear to all.
Another question. Hello.
Would it be okay if I play the video and then we take the questions?
Okay.
Thank you. Can you see my screen?
Yes, sir.
Let me know if the audio is coming through or not.
Okay.
Hello,
Yeah,
everyone.
audio is fine, sir.
Okay.
We are at ICICI Rural Self-Employment Training Institute, Jodhpur. This is a building built by ICICI on complete green principles. It's a 100% green building. This is getting inaugurated today. We are here, the northeast corner, looking at the building outside view and also overseeing a 20 KLD sewage treatment plant, which takes care of all the wastewater coming from the canteen, kitchen, and the human consumption. The water gets into this screening chamber where it gets filtered for all kinds of plastics or solids if they're coming into this waste, and then goes into this wet well. The wet well is closed. There is a pump installed here to do single stage pumping into this holding tank. This holding tank has a 1-day retention. Then the overflow goes into this wetlands. Here is the first wetland. This is a very newly built system. It's getting established, so we don't see enough population of the plants, but it's performing already. And then from the first wetland, we have an inoculation tank, and it goes into the second wetland. The system is well established. Plants are growing well, and the water is already being used for gardening and other purposes here. Part of the water gets back into the flushing. So it's been 3 months. The system has been operational. Probably in about 3 more months, you will find a lot more diversity in terms of the plants. We did the plantation during summer, so some of the plants didn't survive lack of water. We will take a shot in another 3 months and probably get an updated video. Thank you for watching.
Now the question.
1 second, sir. I'll play another video for you.
As the operation and maintenance cost of STP is much more than the installation cost, then what to do?
You can't help it, sir. That's the nature of the beast. If you buy a car, Skoda, and it gives you 6 kilometers per per liter. We can't help it. That's how the system is designed. So we have to look at before setting up the system itself, we have to be cognizant of the cost involved. So accordingly, we have to choose the system. If you have already installed a system and you're incurring a lot of expense, you have to examine what and all you can do. In couple of cases where I have visited some campuses, I have presented an option where they, even after commissioning the system in 2 years' time, they have let go some of the treatment mechanisms and they converted it into a wetland system. And they calculated their ROI over a period of 10 years. They felt very satisfactory after that, we did a good thing by bringing wetlands, even after spending money on the conventional system.
Okay.
I'll share a video of another system. This explains a lot of science. This may be helpful to all of you.
Welcome to Blue Drop Enviro. Today I'm going to take you through a live video of one of our sewage treatment plants in Hyderabad. You can see the wastewater coming in from various sources into this holding tank. This holding tank is designed specifically for sewage treatment functionality through constructed wetlands. Here you can see the first basin of the constructed wetlands having healthy plants, and they have grown close to about 9 feet tall. These are surface ponds. You must be wondering why this is gravel, what is this liner? See, the whole principle is that this wastewater shouldn't get in touch with any soil, so causing soil pollution. So we line this surface ponds designed for the wetlands with HDP liners and geotextile liners. And the entire hydrology is designed based on the pollutant level within the wastewater. You can see the extent of treatment plant. There are various sections of different plantation you can see. Anybody passing by probably feel that this is a park, may not even notice that there is something happening at the root zone. The entire action happens at the root zone of this treatment plant. These plants are aquatic plants. You can see the tubular structure of this stem. This plant that we are seeing is Cyprus papyrus. You have heard about paper. So the paper manufacturing was produced out of these papyrus plants in the olden days. So the gravel is installed in different layers ranging from 10 mm to 60 mm, and the entire hydrology design on the pipelines are laid below the gravel, and various species of plantation is done. The way these plants are thriving, if you take the same plant and plant it over a ground in soil, it wouldn't grow this much. These plants thrive on these pollutants that we don't like. Well, they are thriving, but at the same time they are remediating the water. In this constructed wetlands, we don't separate the waste from the water. We actually remediate the waste. The sludge is consumed in the holding tank partially, and at the root zone system of these plants, there are microbial colonies that develop and they proliferate significantly. And we provide a large surface area for these microbes to encroach on. That's where the pollutants settle, and then the microbes act on them. And the roots are so well established in this gravel that there is a microfiber root system that develops at the root zone. This is a Canna species plant. You can see the flowering. So while I was describing this root system, at the root, these plants release hydroxyl ions. Nascent oxygen available. That's where the majority of the water remediation happens, along with the microbial action. And you can see the output quality of water. It's odor free, color free, and meets the PCB norms any day. The BOD levels are way below 30s and COD are below 100. In this system, we have never used any chemicals. There is no mechanical equipment present, and you don't need any technical people here. So a lot more can be spoken about this, but in want of time, I would conclude that this is the most natural way of treatment, and this is sustainable, economical. It brings a lot of biodiversity and ecological balance together while treating the water, which is the primary cause. Thank you for watching this video. Any questions, please contact us to take it forward. Thank you.
All right. So that's all from my side. I think we're also close to the 1.5 hour window. Any questions?
So there are a couple of questions in the chat box.
Okay.
If you can have a look. The question is from Santosh Kharole. What kind of technology Israeli have for treating seawater for drinking purpose that India doesn't have?
I think we are catching up with the desalination plants ourselves now. Adani and many other groups are setting up desalination plants extensively. It's very expensive technology, desalination, but it's, I mean, probably not a concern for a small scale or individuals like us. It has to be at a government scale only. And companies like Adani are setting up thousands of crores of value projects for desalination. And there is a continuation to this question, right? Where do Indians lag behind as far as adoption of advanced technology in the field of water and wastewater treatment plant design is concerned?
Excuse me, Gangadhar, let me just answer for this. Already I think I replied to the professor actually. In fact, this technology was based on the seawater membrane based, which is a lot of leading membrane manufacturers today introduced in the worldwide actually. And it is all the polyamide based membranes actually, which is available nowadays in India also. Of course, near to the Chennai, 2 plants has been successfully installed, commissioned, and it is in operations, nearly about around 30 MLD plants actually. So there is no, as such, there is no separate Israeli technology. It is all based on membrane-based technology only, but it's with the seawater membranes. That's all.
Wonderful, thank you. So for the other question, when it comes to countries like Israel, they are very ahead. They have adapted things. Here I find it's not critical comment. There is no fun in talking negative of anything, but it is like a mob approach. What we have, everybody sets up something. Go ahead, set up that same way. Don't even think about it whether it's suitable. Like I said, in a sustainability matrix, we have to evaluate what technology suits better for us. What are our needs and what is our capital, ability to. And the such study has not been done in many places. People just go, somebody has set up this, it's easy, call that same vendor, do it. I have seen that approach across India, having traveled a lot. I find it very, very difficult to educate people, to tell people that these systems work. Although I've done 70 projects, every day is a litmus test for me. Would system work? This is a question everybody asks. They're working, there are 70 systems there. But a lot of people are setting SBR systems. What do I do? I can't help it, sir. It is the time that people have to spend to understand the options. And one thing is not availability of information is also difficult in India. A lot of people, you probably would never have heard about our company or our work if this session wasn't there. Some of you would have been familiar with wetlands, but you would not know who to approach to understand this wetland science. So lack of awareness is one thing. And even when the options come in front of people, people do not do their homework to learn. Innovation is happening every day. There are very many treatment technologies coming into the game, but all of them have to be measured against the sustainability matrix to qualify what suits one's purposes.
Reddy sir.
Yes, please.
I am Prakash Shetty speaking. Say all type of land can be converted into wetland?
No. When you say aquatic plants, right? In the wetland.
Yeah.
No, not every plant. If you put a banyan tree in under a waterlogging condition, it will die. Even the biggest banyan plant will die in a couple of months if it is under waterlogging condition. They cannot survive.
No, I am
banana
talking.
Trees, yeah. So
wetland.
Wetland.
Now, yeah. So whether all type of land can be converted into wetland?
Yeah. You can convert into wetland. But the question is, you want to convert that into a constructed wetland for treatment purposes, or you want to convert them into a marshy wetland where you want to grow natural wetlands?
Say, for example, if you consider a land which is full of laterite,
okay,
then it is very difficult to plant anything on that particular area.
Naturally, because the water doesn't stop, it will get into it's because very porous. Water even doesn't stay there in that land.
So
you have to.
How to improve that?
We cannot improve that, sir. You go to desert and you cannot store the water. It doesn't stay. It's a porous land. So in cases where you want to store the water, you do membrane. You actually line the soil with membrane where you can store the water. And if you want to grow a constructed wetlands in that place, you excavate it. You put liners where the water doesn't seep. Otherwise, the water seeps constantly. So. And purpose is, why do you want to create a wetland there? You have to go by what purpose does it serve creating a wetland in that area. So it depends on application of wetlands, where you want to apply, why, and that dictates, what the possibilities.
Okay, thank you.
Most welcome, sir.
There are a couple of more questions, sir. The
Sure.
next one is from Tania Sengupta.
Okay.
The time taken by the aerated wetland technique will be much more than that of the conventional technique. She's asking about it.
Right. Is she still in the forum or did she leave? She's here. Okay. All right. So the time taken for treatment, yes. Initially, when we commission the system, let's say typically there's a holding tank that has 1 day retention, then there is wetland system that takes another day to treat. So the water, if you take one volume of water coming into the system today, Monday morning, if you trace that water, if it doesn't mix with any other water, say that block of water is moving forward to the holding tank and wetlands, it will take about 48 hours for that treated water to come out. So there is a 48-hour lag in the system that we see when we commission the system first time. But once the system is commissioned, it's functional for a couple of days. The entire system is under waterlogged condition, that end to end, there's full water in the system. So now any bucket of water comes into that, pushes another bucket out. Now it becomes a continuous system where you would not even notice that it has taken 48 hours to treat. So the question will become irrelevant with the moment the system is commissioned and the system starts to function in a continuous system. These wetland systems, what we are designing are continuous systems, meaning 1,000 liter comes, nearly about 700 to 800 liters goes out. Rest of it is consumed by the plants and trans-evaporation losses. So it's a continuous system. We don't experience that lag.
So there is one more question from Samir Nimkar. How constructed wetland can handle variable BOD load?
I think I explained earlier that, they're inbuilt with a lot more complex biological mechanisms. So they can tolerate that shock loads. They can actually treat it. In the case where you are giving urea to a farm, you're given, let's say, a couple of kgs of urea for 100 square meters. The plant has grown so much. If you give another couple of kgs, it may grow more. But there is a limit to how much it can take. After that, it saturates. Similarly, in the wetland scenario, when the load goes higher, instead of 4 leaves, the plant will have 6 leaves. Instead of 4 flowers, it will have 6 flowers. It will grow. It will take that load. It will grow. But there is a saturation limit after which it doesn't grow. It cannot handle. So there is naturally inbuilt shock load mechanism in the wetlands. That's one thing. Second thing is, I mentioned earlier that per se, if we notice that there are higher loads coming in, variable loads, we also dose additional bacteria into the water in the holding tank itself. So it can treat the water and reduce the load a little bit in the holding tank itself before it goes to wetlands. So we augment or supplement the bacteria that is naturally produced at the root system. So that's how it handles.
Okay, any other questions from participant side? No questions? Okay, sir, we shall wind up the session.
Wonderful.
Thank you, sir. On behalf of Department of Mechanical Engineering, MSRIT, I heartfully thank you for accepting our invitation and delivering such an informative talk on waste management. Thank you, sir.
Thank you very much.